Hello student, I am Mahazbeen Assistant Professor, Department of Applied Science and R&D Profile Faculty, SIRT. Today we are discuss about the principle of superposition, subject Fundamentals of Physics, CV 105 for branch CSBS first semester. The topic principle of superposition is most important by which we can easily explain the interference of light in wave optics. The topic principle of superposition basically coming from the unit number 2, interference principle of superposition, Young's experiment, fundamentals of physics CV 105. So today we discuss only about principle of superposition and rest of the topic we will discuss in my upcoming video lecture. So let's start. These are the contents which are relevant to the topic wave, principle of superposition, principle of superposition mathematically, superposition of waves in same phase, maximum displacement, superposition of waves in opposite phase, minimum displacement, condition for superposition. So, what is wave? It is a disturbance that transfer energy from one point to another without transporting matter from the medium itself. This transfer of energy can occur through a physical medium such as sound waves traveling through air or even through a vacuum as in this case of light waves. So waves can be classified as mechanical or electromagnetic. For mechanical wave which require a medium, but for the electromagnetic wave which do not require a medium. And they exhibit fundamental properties such as frequency, wavelength, amplitude, and speed. So these properties we can easily explain by this figure. So this is the figure of the wave, and the wave is propagate along to the x direction. This is called wave movement. The maximum displacement upward direction is called amplitude, as well as maximum displacement in downward direction is also known as amplitude. Peak point of the upward direction is called wave crest, and the peak point of the wave in downward direction is known as wave trough. And the distance between two crest or two trough is called wavelength, which is denoted by lambda. So, principle of superposition. According to the principle of superposition, when two or more waves overlap in space, the resulting disturbance is equal to the algebraic sum of the individual disturbance. A necessary condition for the superposition principle is that amplitude must be small, such that the waves do not scatter. Superposition is an important concept as it can explain many phenomena in physics. The interference and the diffraction of waves are based on the principle of superposition. This principle holds for many different kinds of waves, such as waves in water, sound waves, and electromagnetic waves. So, we can explain in other words, when two or more waves cross at a point, the displacement at that point is equal to the sum of the displacement of the individual waves. Explanation here. You can see two waves in red and green superposing. That is red and green. Both are superposing at a point 3 and at that point to form a resultant wave in purple color. That is the resultant wave. The resultant wave having greater amplitude because the amplitude of the resultant wave achieved by the added of both amplitude. So, it helps in explaining the phenomena like interference, where waves add up, constructive interference, or cancel out destructive interference. Principle of superposition mathematically. So we consider the two waves. First wave having displacement equation represented by y1, and second wave having the displacement equation y2. So if the individual waves are represented by displacement equation y1 and y2, the result wave displacement y is given by y is equal to y1 plus y2. That is the algebraic sum of the displacement of individual waves. So when the two waves are superimposed or overlap to each other, so we get this resultant wave. So the displacement of this resultant wave y is calculated by this equation. Superposition of wave. We need two or more waves. So here we consider the two waves, that is first wave and that one is second wave. Both are propagate linearly and crossing to each other in different points. After the superposition, we get the resulting waves, that is the resulting waves. This is called superposition of waves. So how to superposition of waves? There are two conditions. First one is when the two waves are in same phase. What is the concepts of the same phase? So here we take the two waves, that is the first wave having displacement y1 and that one is another wave having displacement y2. Both are propagating linearly in a medium. The crust of the first wave coincides the crust of the second wave, due to which the amplitude of the both wave added them and we get the resultant wave. This is the resultant wave. This achieved by the amplitude of the both wave are added. If we consider here the amplitude of the first wave is 1.0 and another wave have amplitude 0.1. So when the two waves are overlapped like crust on crust or trough on trough, that means crust coincides to the crust. So the amplitude of the both wave are added and we get the resultant wave. This is also the resultant wave. In this situation, the displacement of the resultant wave is maximum. And if the superposition of waves in opposite direction or in opposite phase. Opposite phase means that the first wave has displacement y1 and another wave has displacement y2. Both are propagating linearly in a medium. The first wave, the crust of the first wave overlap to the trough of the second wave, due to which the amplitude of the wave are subtract. So we get the minimum displacement. When the two waves are superimposed like this, crust on trough. So the amplitude of the wave, first wave having 1.0 and another wave having the amplitude 0.9. So their subtraction, we get the result of the amplitude is 0.1. So this is the resultant wave having amplitude 0.1, due to which the displacement of the resultant wave is minimum. Condition for superposition. First, same type of waves. The waves must be same nature. For example, two transverse waves or two longitudinal waves. But a transverse and a longitudinal waves cannot superpose. Condition: the waves should propagate in linear medium so that their amplitude can simply add algebraically they meet. The principle of superposition does not require coherent and monochromaticity. The meaning of coherent, that means both wave in same or constant phase. And monochromaticity means both wave in single color. But To see visible, study interference in light. So we need coherent, that means constant phase, and monochromaticity are essential. Thank you.